Hi, this is Algebra 2, Lesson 43. We're going to talk about sine, cosine, tangent, and inverse functions, and we're starting on page 190. So today is a preview of trigonometry and trigonometric functions, and we're going to talk about sine, cosine, and tangent. So with any right triangle, the side opposite the right triangle is called the hypotenuse. We've talked about that before. So here we have three right triangles. The side opposite this right angle is 4. The length of the side opposite this right angle is 120. And the length of the side opposite this right angle is 240. So those are the hypotenuses. Each of these triangles have 30-degree angles. And so therefore these are similar triangles. So because this angle is the same in all three triangles and this angle is the same in all three triangles, that means this angle has to also be the same, right? We've talked about that before. So these are similar triangles, which means that the ratios of the corresponding sides are going to be equal. So if we take the ratio of the side opposite the 30-degree angle and put that over the hypotenuse, the ratios for all three of these should be equal. So for this angle, or this triangle, the ratio of the opposite side over the hypotenuse is 2/4. For this triangle, the ratio of the side opposite the 30-degree angle over the hypotenuse is 60/120. For this triangle, the ratio of the side opposite the 30-degree angle over the hypotenuse is 120/240. In all three cases, when you simplify these ratios, you get 1/2, or 0.5. We call this the sine of the triangles. The sine is the opposite side of whichever angle we're working with over the hypotenuse. So we would say that the sine of 30 degrees, and notice we dropped the e, this is not sin, this is sine when we're talking about math. So the sine of 30 degrees equals the side opposite the 30-degree angle over the hypotenuse, which equals 0.5, or 1/2. This is going to be true of any right triangle that contains a 30-degree angle. The sine of the 30-degree angle is always going to be 0.5. The ratio of the opposite angle over the hypotenuse is always going to be 0.5, or 1/2. The ratio of the side adjacent to the angle over the hypotenuse is called the cosine of the angle. So to find the cosine of 30 degrees, we take the side adjacent to the 30-degree angle. So in this triangle, that would be this side. So it would be 3.464 over the length of the hypotenuse, which would be 4. And this is going to equal, on this triangle, the side adjacent is 103.92 over 120 is the hypotenuse. On this triangle, the ratio is going to be 207.85 over 240. If you punch these ratios into your calculator, you're going to find that it comes out with 0.87. So what is true is that any right triangle containing a 30-degree angle, the cosine of that 30-degree angle is always going to be 0.87. Okay, tangent. The ratio of the side opposite the angle to the side adjacent to the angle is called the tangent. So now we're not using the hypotenuse. We're doing the opposite side over the adjacent side. So if we flip over once more, we can see this one is going to be opposite over adjacent, so 2 over 3.464. This one is going to be opposite over adjacent, so 60 over 103.92. This one's going to be opposite over adjacent, which is going to be 120 over 207.85. Okay? And if we punch those into the calculator, we're going to find that the tangent of 30 degrees is always 0.58 for any of those ratios. When you do trigonometry and calculus, you will be memorizing the sine, cosine, and tangent values for many common angles in degrees and radians. For now, though, we just need to know how to figure them out. As a group, we call these trigonometric functions. And this will be useful to memorize now because you're going to be using it many, many times. The sine of angle A is the opposite side over the hypotenuse. So sine equals opposite over hypotenuse. The cosine of angle A is the adjacent angle side over the hypotenuse. The tangent of A is the opposite side over the adjacent side. Your book suggests memorizing these with the mnemonic Oscar had a hold over Arthur. So for sine, it's opposite over hypotenuse. For cosine, it's adjacent over hypotenuse. And for tangent, it's opposite over adjacent. I simply learned SOHCAHTOA, which is sine opposite hypotenuse, cosine adjacent over hypotenuse, tangent is opposite over adjacent. So Oscar had a hold over Arthur, if that works for you, and you can remember the orders sine, cosine, and tangent, or SOHCAHTOA, just sine opposite hypotenuse, cosine is adjacent over hypotenuse, and the tangent is opposite over adjacent. Either of those work. Pick which way works best for you, but you do need to memorize this because you're going to be using it in math and physics for years to come. SOHCAHTOA, or Oscar had a hold over Arthur. On your calculator, you probably have sine, cosine, and tangent buttons. If your calculator does not have these, it's time to upgrade to a scientific calculator. If you will be taking pre-calculus and calculus down the road, you might want to look into a graphing calculator. However, you will not be using the graphing capabilities in this course. Regular scientific calculators are very inexpensive these days. Do not just rely on your phone. You need a real scientific calculator. Okay? For this course, when we are finding sine, cosine, and tangent, your calculator needs to be in degrees mode. If your calculator is giving you different answers than this video or your book are giving you, your calculator is probably in radians or gradients mode. Some calculators have a DRG or a degree button that will change the mode. Push it until your calculator says degrees, usually in little tiny letters. So if it's giving you, the sine of 30 degrees is not giving you 0.5, but is instead giving you negative 0.988.0316241, you're in radians mode. So find the DRG or degree button and push it until it says degrees, and then when you do sine of 30 degrees, it should say 0.5. Okay? I have a graphing calculator. It's not very new. It's a Texas Instruments 82. There are newer ones than this. On my calculator, I push mode. I don't know if you'll be able to see this, but there's this button here that says mode, and it takes me between degrees, radians, and grads, which you're not going to be using at all in high school, but you may use them in college. Okay, so on my graphing calculator, I push mode, find the radian degree option, highlight degree, and push enter. Okay, so it's a menu in there. On a lot of just scientific calculators, you just push the degree button until it says DEG or degrees. So now when I enter sine of 30 degrees, I get 0.5. The calculator in your book, the calculator that the book writers used, requires you to type the angle first and then sine. My calculator, I push sine and then 30 and then enter. So you need to play with your calculator and figure out which way it works and which way it gives you the correct answer. So if we're doing the sine of 39.2 on my calculator, I would actually push sine and 39.2, enter. The calculator that the book uses would punch in 39.2 and then sine and then the equals button. They give you the same answer. So you need to stop the video now and figure out which way your calculator works. Okay? Okay, most of the time I'm going to be writing these the way that the book's author does, just to keep things consistent. But you put it into your calculator the way it works on your calculator. So, the cosine of 39.2 in the book's method is going to be 39.2 and the cosine button and enter. And that equals 0.7749. Okay, most of the time we're actually going to stop at 2 decimal places and we're going to round up. So in that case, this would be, this 9 is going to change this to a 5. The 5 is going to change this to an 8. So we'll be at 0.78. Okay? The tangent of 39.2 is 0.82. It's actually 0.81558000988. But we're going to stop at 0.82. Often as we do these problems, you will be multiplying the trigonometric functions by some number. So here we have 4 times the cosine of 57.2 degrees. So this means 4 times the cosine of 57.2 degrees. In the book's calculator, they actually punch that in. 4 times 57.2 cosine equals. In my calculator, you hit 4 cosine 57.2, enter. Either way, it equals 2.1668, or we would probably write 2.17. So for convenience sake, unless otherwise specified, we're going to round these answers to 2 decimal places. Okay? Alright, here's an example. Find A, the sine of A, B, the cosine of B, and C, the tangent of C. Round your answers to 2 decimal places. So in this case, it isn't giving us the angle. We are just going to figure out the sine using the sides that we are given. So here is angle A. It is opposite this side, and this side is opposite the right triangle. This side is opposite the right triangle. So this side is the hypotenuse. And for sine, this is A, the sine of A is going to be the opposite side of the angle we're working with over the hypotenuse. So that's going to be 4 over 7. And when you punch that into your calculator, it is 0.57. Okay? Let's try another one. B. For B, we're looking for the cosine of B. Here's the here's the right angle, so that this is the hypotenuse. This is the adjacent side. So the cosine of B is going to be the adjacent side over the hypotenuse, which is 7 over 8.6. And that is going to come out to 0.81. Okay? For C, we need the tangent of C. Here is angle C. This side is opposite to the right angle, so this is the hypotenuse. For a tangent, we need the opposite over the adjacent. Opposite over adjacent, which is 6 over 8, which is going to equal 0.75. Okay? Now we're going to talk about inverse functions. If the sine of 30 degrees is 0.5, then the inverse sine of 0.5 is 30 degrees. Sometimes we're going to start with the value of sine, and we will want the degrees of the angle. We will find this with the inverse sine. So this is the inverse sine of 0.5 is 30 degrees. If the cosine of 30 degrees is 0.87, the inverse cosine of 0.87 is 30 degrees. If the tangent of 30 degrees is 0.58, then the inverse tangent, and sometimes we write it like this, might be what your calculator says also, tan with a -1, that's the inverse tan of 0.58 is 30 degrees. Okay? Once again, you'll need to figure out how to make this work on your calculator. The book author's calculator has an inverse button, so he pushes 0.5 for the inverse sine, 0.5 inverse sine equals, and he would get 30. On my calculator, I have a sine to the -1, or an inverse sine, written above my sine button. So I use the second function button to choose the sine inverse. So I would hit second function, sine inverse, which is really the sine button, and the 0.5. And then push enter, and I would get 30 degrees. Okay, so stop and play with your calculator right now and figure out how to find the inverse sine and inverse cosine and inverse tangent. Okay, here's a problem using the inverse sine and inverse cosine functions. Find A, the angle whose sine is 0.643, and B, the angle whose cosine is 0.216. So we're looking for the angle, and what we know is the sine. So for A, the inverse sine of 0.643. You punch this into your calculator, and you're going to get 40.02 degrees. Once again, we're going to end with a rounded up to the second decimal place, to the hundredths. Okay. B, we have the inverse cosine of 0.216, and you punch that into your calculator, and you get 77.53 degrees. Okay. So play with your calculators until you can get these correct answers on it for both the cosines and the inverse cosines, and tans and inverse tans, and sines and inverse sines. Okay? And then try your practice problems and your homework, and let me know if you have any questions. Thanks.